now you are the particles of iron. I am the magnet. Okay? And you're all looking at me. Watch it. Watch it. The magnet is moving. The magnet is moving. Watch me. Watch me. Watch me. They're all looking at me now. Have you changed? No. Is something being magnetic, chemical, or physical? Physical. Physical. We did not change the atoms of iron. We just turned them around. That was a good example. All right. What number are we on? 17. Thank you. Examples of intensive physical properties. Okay. Well, let's stick with our iron example. Intensive physical property. Magnetic, gray, flaky, 3 grams.
3 grams.
3 grams is not, because not all, iron isn't iron because there's 3 grams of it. But iron is magnetic, it's a solid, what else did I say? Brown, it's flaky, well, it doesn't always have to be flaky if you melt it down, but, so flaky could be an extensive physical property as well.
So intensive are the more helpful ones.
Intensive are more helpful. They're the ones that describe a substance no matter how much you have or what shape it is or how much you grind it up. Lily?
What's BP and everything?
Boiling point and melting point. BP is boiling point, MP is melting point. Yep.
Are those intensive or extensive?
Intensive. A drop of water will boil at 100 degrees Celsius at sea level. A lake full of water will boil at 100 degrees Celsius. Alrighty. 18. Examples of chemical changes. So this will sound very much like your physical chemical properties lab. Okay? And examples like that. So evaporating away a liquid from a solution. Physical. Allowing a solution to cool and crystals form. Physical. Pouring one solution into another and a bright yellow precipitate forms, like you saw on Moodle. Chemical. Who saw that on Moodle? All right, who's going to go look at it on Moodle sometime before Friday's test? Awesome.
I have a question about
Yes.
cobalt. Would that be like how it changed colors because like the dryness or like humidity? Would that be
In the cobalt chloride,
yeah?
that has to do with the humidity, yeah.
Would that be a chemical or physical change?
Well, if you looked at all 3 of those, we went from pink to blue to pink.
Yes.
So we could easily undo that just by, we heated it, got rid of the water, and then it absorbed the water back.
So can you say some indicators of both chemical and physical changes?
Well, physical changes you need to look for, or you need to think about, did I really change what the atoms and molecules are by doing this? Crushing, bending, melting, boiling, dissolving, evaporating, those are all physical, and many more. Chemical, a lot of times we get hung up on that because there are many new physical properties that happen to tell us that a chemical reaction has taken place. So that's where you got to go back to that list, our list of evidence. Heat or light is given off, like the glowing red in the substance today. A gas is produced, which was the very last thing you did today, that is stinky and memorable, right? A precipitate being formed by 2 solutions coming together, forming a solid. Electrical energy, like in a battery. The chemical reaction going on in a battery produces electrical energy. And in some, it's mechanical energy, but we don't test those here in chem class. Okay, so that's 18 and 19 are physical versus chemical. 20, 21, and 22, the properties and identifying characteristics of each state of matter. Basically, what distinguishes a solid from a liquid from a gas. So at the particle level, in a solid, things are packed closely together. There's a lot of attractive force between the particles, and they don't move around too much. They move some, but they don't move too much, those particles. So they'll take a definite shape and a definite volume. In the liquid state, the particles are moving a little more, but they're still attracted to each other, and they can slip and slide past each other. There's less attractive force, more movement. They will take the shape of any container they're in, but they do still have a definite volume. So they're the intermediate between solid and gas. And in gas, there's a lot of energy for the particles. They're widely spaced apart. They're moving around like crazy. There's not much attractive force between the particles at all. They will fill up any container you put them in, and there's no shape to it. So any shape, any volume for gas, definite shape, definite volume for solid, and one of each for liquid. Okay, so that covers really 20, 21, 22. '23, examples of pure substances versus mixtures. And they're almost all common household things. They're all certainly things that you would have experience touching, dealing with, and so on. Probably the hook in this question is what a solution is. The hydrogen peroxide you have at home in your medicine cabinet is actually a 3% solution of hydrogen peroxide dissolved in water. So hydrogen peroxide by itself is a compound. Water by itself is a compound, but the bottle you have at home is a solution, so it's a mixture. Same thing with the vinegar in your kitchen, or probably maybe the bleach or the ammonia that you have for cleaning products. Okay? And remind me tomorrow, I want to quiz you guys on my samples of mixtures and figure out. I'll show you some real-life examples of those tomorrow so everybody can see it in class. All right, 24 is one of those pesky questions that has pictures. And there are 4 pictures, and the pictures are labeled A, B, C, and D. But you may end up...
Can I grab your keys really fast?
Yes.
The art room box, and I forgot to take my
You're on camera. So this has 4 pictures, and but the answer choices get scrambled when we make the version of the test. So picture A might be answer choice C, or picture C might be answer choice B. Okay? Are you understanding me or no?
Yeah.
So we have picture A, B, C, and D. So that's what my pictures are going to look like. And then my answer choices, underneath it, answer choice A might be picture C. Answer choice B might be picture B.